Hello everyone, it's Mr. Fahd again. Today we will continue with our unit on differentiation, the product rule and the quotient rule. By the end of this lesson, you should be able to apply the product rule and the quotient rule on derivatives. Alright, so if you have two functions multiplied together and you want to find the derivative for them, then you don't simply find the derivative for the first and for the second, but you will use the product rule. So the product rule says the derivative of the first times the second plus the first times derivative of the second. That's it. We will just apply it. Here's an example. Find the derivative of this function. And you can see you have two expressions multiplied. Each has variables. So we need to use the product rule. If this is the first function, we'll consider this to be the second function. Then the derivative will be derivative of the first times the second plus the first times derivative of the second. And you just simply do the power rule for this. So this will be 2x. This will remain the same. Here it's the same, and here the derivative will be 3x squared minus 3. One will have the derivative of 0, so you don't have to write it. That's it. Now you can just distribute and simplify the expression. So 2x will be multiplied by x cubed, and then 2x will be multiplied by negative 3x, and then 2x will be multiplied by 1. And here we will do FOIL, so you'll just multiply the first with the first with the second, and then the second with the first, and then the second with the second. Now we combine like terms. So for power 4 you have 2 and 3. This will be 5x power 4. And for power 2 you have negative 6 minus 3. This is minus 9 plus 9 will cancel out, and you'll be left with 2x minus 9. All right. Let's take another example. In this exercise, we've given the values for the function, the derivative of f and g at certain points, and we need to find the equation of the tangent line for the function h of x at the given point, so at x equals 0. Now, notice that h of x is the product between f and g. All right, so at x equals 0, we will just substitute 0 in x equals negative 1, g of 0 equals 3. This is given in the question. And h of 0 will be negative 3. So I know now that the point is at 0 and negative 3. Remember, the question is asking about the tangent line. So the equation of the tangent line, I need the point and then I need the slope. In order to do the derivative for h of x, we will use the product rule, and then we will substitute from the given information. So at 0, I'm looking at the derivative for f at 0, which is negative 1. So I'll substitute negative 1, g of 0, and g of 0 is 3, and then f of 0, and so on. Okay, so you can see the slope here is negative 2. And now you can write the equation of the tangent line. There's more than one formula to do this. We will choose this formula. So y minus y naught equals m, x minus x naught, where x naught, y naught, the point that we have. So plug in the point here, and you have the slope at negative 2 again. Now solve for y, so isolate y on one side, and this will be the equation of the tangent line.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. Okay, with that said, let's get back to our lesson.
All right, next we have the quotient rule. So just like the product, you can't just distribute the derivative for the quotient. we will be using the quotient rule. And simply it says the derivative of the top times the bottom minus the top derivative of the bottom over the bottom square. You can also remember it like this, low d high minus high d low over the square of what's below. So d means the derivative, high and low, the top and bottom. Let's practice on this rule. So find the derivative of g of t. You can see here the function is a rational function, so it's a quotient. We will just apply the quotient rule. Derivative of the top times the bottom minus the top derivative of the bottom over the bottom squared. And now derive this. It will be 3, and the derivative for this will be 5. Now simplify the top. You have 3 times 15, 15t, and 3 times 1, and then 15t plus 10. Okay, now I can see 15 and negative 15 will cancel out. I'll be left with 13 over 5t plus 1 all squared. As you can see, this is relatively simple. You just follow the rule and derive the expression simplified. Another example. Okay, so they gave us some points for f and g and its derivative. Find the equation of the tangent line to the graph of this function, h of x equals x squared over g of x at x equals 1. So if you recall, we need to find the point first and then find the slope and then write the equation. Try to pause the video and do it on your own and then come back to check your answer. All right. So the solution here, first, let's find the point. So at x equals 1, I'll plug in 1 instead of x here, and this will be 1 over g of 1 will be 1. So the point that we have here is 1 and 1. Now we will do the slope. So applying the quotient rule, you can see here derivative of the top times the bottom minus the top derivative of the bottom over the bottom squared. Let's find the slope at 1, substituting 1 instead of x, and these are given, g of 1, g prime of 1. From the given, this will be 1 and negative 2. Again, negative and negative will be positive over 1, which will be 4. So the slope at x equals 1 is 4. Now just write the equation of the tangent line, and we will use the same equation here. So substituting the point that we have 1 and 1, and the slope is 4, solving for y, this will be 4x minus 3. Okay, let's move to the last part of the lesson. We have this example about investing. It says, suppose that a product sells for 25 dirhams with a price increase at the rate of 2 dirhams per year. At this current price, consumer will buy 150,000 items, but the number sold is decreasing at the rate of 8,000 per year. At which rate is the total revenue changing? All right, so they're asking about the rate of change for the revenue. Is the total revenue increasing or decreasing? All right, so in order to solve this, first you need to understand that the rate of change is the derivative. I can see that the price here is 25 and the rate of change, so B prime is 2, and also the sales here or the quantity is 150, and the derivative of the quantity here is 8. So now I can express the revenue as the price times the quantity. Again, let's write what's given here. So the current price, the derivative for the price or the rate of change, and also the quantity, current quantity, and the rate of change for the quantity. When I say negative 8, because it's decreasing, so if it's increasing, it will be positive, just like the slope. Now remember, the question is asking about the current rate of change for the revenue. So the revenue equals the quantity times the price. You can think of each one of these as a price of time, because again, it's changing right? So the derivative for each of these will be r of t, and the derivative will be using the product rule. So r prime of t will be q prime of t, derivative of the first, times the second, plus the first derivative of the second. Now all of these are given. It's right here. So let's substitute at 0, because we are looking for the current rate of change, meaning not the future one. So t equals 0, right? And substitute the given values. Once again, it's right here. We substitute the values, and this will be 100,000. Again, it's rate, so dirhams per year. And to answer the last part of the question, it's increasing because it's positive, right? That's it for today. Thank you so much for watching.